I'd like to take a moment to talk to you about some of the math we'll be using in this class. I'm on page 28 of the textbook. I'm using an electronic version of the textbook so that I can show you things. Notice on this page, we're referring to what's known as the energy utilization index for a facility, and which is the ratio of the total BTU consumed by a facility to the total number of square feet in the conditioned space. The example that they're showing us here is a 100,000 square foot floor space building that uses 1.76 million kilowatt hours of electricity and 6.5 million cubic feet of natural gas in a year. So we need to convert this, as it said in the definition here, we need to convert the kilowatt hours and the cubic feet of gas into BTU. So that's what we're going to show how to do in this example. So they've got a couple numbers in here that they got out of a table, and that table is on page 9. So I'm going to go back up here and go to page 9, and notice page 9 shows table 1-1 with lots of different conversions and energy contents. The first two that we need are right there at the top. 1 kilowatt hour, as it shows here, contains 3,412 BTU of energy. And furthermore, 1 cubic feet of gas contains 1,000 BTU of energy. So that's where these numbers came from. We can get that information from many other places, smartphones, websites, who knows. You may have that you just may remember it. A couple other things I want to point out here. For example, notice down here I have this highlighted, the capital MCF. Now in electricity classes, we refer to the letter M, uppercase M, as mega or million. Well, not so when we're doing this type of work. In this case, the M would be like the Roman numeral M. So uppercase M is equal to 1,000. If I wanted to do a million, we don't have a million in Roman numerals, except down here you'll notice if I take M times M, 1,000 times 1,000 is of course a million. And we also show that in the exponential notation of 10 raised to the 6th power. So just a couple things. We'll be looking at this page lots more, but for now let's go back to page 28 and do that little bit of math. So you'll notice in your textbook looks just like this. It shows where we're going to have the amount of energy use, and this top line here, we're going to convert the kilowatt hours into BTU, and we're going to add that to this next line where we convert the amount of gas and we convert that to BTU. So the next line, they're showing it simplified. So it turns out to be 6 times 10 to the 9th, exactly 6 times 10 to the 9th. How did they do that? And 6.5 times 10 to the 9th. All right, so let's see exactly how they did that. It might be a little confusing. I've added something at the bottom of my page that you don't have on yours, all right? And that's going to be this right here. So we're going to do some cross multiplication and canceling here, right? So if I take the 1.76 right here, and I multiply that times 10 raised to the 6th, that's what that's showing here. 10 raised to the 6th is 10 million. Kilowatt hours is the what we're measuring in electricity, but to convert that, we multiply that times 3,412 BTU, which is the amount of BTU in 1 kilowatt hour. So you'll notice now that because I have a kilowatt hour both in the denominator and in the numerator side of this equation, that they can cancel each other out. So rather than line them out, I've just highlighted them. So what'll be left would be the 1.76 times 10 to the 6th times 3,412, and this is that answer down here. And that number, of course, would be the number of BTU. We're going to do the same thing now to the second half of this, the 6.5 million cubic feet of gas, 6.5 times 10 to the raised to the 6th. That's this raised to the 6th thing. Sometimes that's called a caret. Cubic feet times the 1,000 BTUs of energy in a cubic foot of gas. And so we have the same scenario here, where this cubic feet is going to cancel out this cubic feet. And so again, rather than crossing them out, I just highlighted them. So when we multiply 6.5 million times 1,000, you end up with 6.5 billion as shown here. And when you add that 6.5 billion to the electricity costs, we can see what the total amount of BTUs being used are. That's this number right here. We then divide that by the 100,000, and that gives us the, now notice the number that I have here is a little bit larger. What they did in the book is they rounded off. I didn't round off. I left the number, everything that was there. So as far as calculators go, I have a calculator built into my computer, as most of you do, I'm sure. I also have a Texas Instruments TI-30XA, which is a relatively inexpensive scientific calculator. They can get them for as cheap as 10 bucks quite often. I'm just going to use the one that's on the computer here, though, and I'm going to make sure that it's converted to work in the scientific mode, and I'll clear everything out, and we'll go through and do this math. All right. So again, let's put in the 1.76. Now this uses the EE key, as does my Texas Instruments. So when I hit the EE, that's just like raising it to the 6th power. So there's the 1.76 times 10 to the 6th, and we multiply that times the 3,412. And to that, then, the next thing we do is we have to do the addition. So we will add that. And when I hit the addition, notice the number it gives me, right? Here's the same number, right? 6,005,120,000. That's the same number I had here. The number of BTUs, 1.76 million kilowatt hours. And I want to add that to the remainder of this formula. So I've hit the plus symbol already. And so now I'm going to use the parenthesis. And when I do that, it shows up as the parenthesis. Now I can put in the 6.5 raised to the 6th power, and we'll multiply that times the 1,000 BTUs that are in a cubic foot of gas. When I close the right parenthesis, we're going to see the product of the two things we multiplied together, right? The 6.5 billion BTUs that are in 6.5 million cubic feet of gas. And then finally, when I hit equals, it will give us the sum of this and the previous number. And so there we go. We can see that number, which is very nice. So that's one way of doing this. I'm going to stop here and show you in the next file. We're going to do this using Microsoft Excel.